Hello and welcome again to another video on chemistry revision. For today's video, we will be focusing on salts and in particular salt preparation. Okay, questions relating to salt preparation. Now, before we can tackle questions relating to salt preparation, it would be very good for you to familiarize yourself with the solubility of salts. So this is what you see is the solubility table. Let us quickly revise that. We see that all nitrates are soluble. All sulfates are soluble except calcium, lead, and barium sulfate. All chlorides are soluble except lead and silver chloride. And for carbonates, it's slightly different. All carbonates are insoluble except sodium, potassium, and ammonium carbonate. Now, this is commonly known as the spa carbonates. Okay. Now, once you have memorized the solubility table, it would be also good for you to know the different salt preparation methods. Okay, so typically, before you can actually say what kind of materials you need to prepare a certain salt, you need to know what kind of salt is it, because the kind of salt will determine the materials you need to prepare the salt. So, whenever you are given a salt, ask yourself first of all, okay, what kind of salt is it? We ask ourselves whether or not the salt is soluble or not. If the salt is not soluble, we are talking about an insoluble salt, and the method we use is precipitation. Okay, adding two soluble substances, typically a nitrate and a spa salt, to prepare an insoluble salt. If the salt is soluble, then we ask ourselves one more question: is it a spa salt? If it is a spa salt, then we refer to the salt as a spa soluble. When I say spa, I mean sodium, potassium, or ammonium salts. So if it is a spa soluble salt, we use the titration method, which is typically involving the neutralization reaction between an acid and an alkali, or an acid and a soluble carbonate. Now, if the salt is a soluble salt but it is not a spa salt, then we usually call it a non-spa soluble salt, and the method that we will use is acid reacting with an insoluble metal, base, and carbonate. And in this particular area, it might be very useful for you to be familiar with all the acid reactions as well. Okay, so now that we've known all that, let us tackle our first question. Which of the following pairs of reactants cannot be used to prepare zinc sulfate? So now we ask ourselves, we are preparing zinc sulfate. So what kind of salt is it? We know this is a sulfate, and all sulfates are soluble except calcium, lead, and barium. So we are talking about a soluble salt. But because it is a zinc salt, not a spa salt, we know that this is a non-spa soluble salt. Okay, so we have classified this salt as a non-spa soluble salt. And we know to make a non-spa soluble salt, we would use an acid plus an insoluble metal, base, or carbonate. Okay, so let's look at what options we have available for us. Okay, so option 1, dilute sulfuric acid and zinc hydroxide. So this would be your acid plus insoluble base. So you could use this method to prepare zinc sulfate. The second option, dilute sulfuric acid and zinc carbonate. So this is an acid plus an insoluble carbonate. So this method can also produce zinc sulfate. Okay, let's take a look at 3. Sulfuric acid and zinc nitrate. Sulfuric acid is an acid, but zinc nitrate is a salt. Okay, sulfuric acid and nitric acid is the reaction between an acid and a salt. Now this will not be able to produce the zinc to prepare the zinc sulfate that we need. Okay, because we are looking at acid plus insoluble metal, base, and carbonate. And option number 4, sodium sulfate and zinc chloride. This doesn't even have an acid. So confirm option 4 also cannot be used to prepare zinc sulfate. So we can see that both 3 and 4 are not suitable to prepare zinc sulfate. The answer therefore is D. Okay, these two methods match the preparation method for non-spar soluble salts, but these two do not, so they cannot be used to prepare zinc sulfate. Now, at any time in the video, you can pause or rewind to certain sections of the video which you think that you might need a little bit more time to go through. Okay, feel free to do that. So now let's take a look at question number 2. Which of the following reactions will cause a decrease in the chloride ion concentration in the solution? Okay, so now we are looking for a reaction where at first we start off with a lot of chloride ions. Okay, we start off with a lot of chloride ions, but after the reaction, the chloride ion concentration will decrease. Now, where did the chloride ions go to when they were originally in the solution? They left the solution. So where did the chloride ions go to, or what happened to it if it left the solution? The only option is it formed a precipitate, because in a precipitate the chloride ions may still be there, but the chloride ions are no more in solution. So we are looking for a precipitation reaction. So that means we are looking for an insoluble chloride. Okay, because an insoluble chloride will take away the chlorides from the solution, causing a decrease in the chloride ion concentration. Okay, so now let us look for an insoluble chloride, and we know that all chlorides are soluble except lead and silver chloride. So in reaction in A, we can see that silver chloride is formed, and we know that silver chloride is insoluble, and this will give us a precipitate, which is what we want, because this will cause a decrease in the chloride ion concentration. Now, barium chloride, potassium chloride, and sodium chloride are all soluble chlorides. That means the chloride ions will still be in solution. Okay, so in this particular case, 1, 2, and 3, the chloride ions are still in solution. So there will be no decrease in the concentration of chloride ions in B, C, and D. So the answer in this particular question is A. Okay, so let's tackle another problem. Number 3, the solubilities of some salts of an unknown metal are shown in the table below. So we can see that for this particular metal, we're talking about the nitrates are soluble, the carbonates are insoluble, the sulphate is insoluble, and the chloride is also insoluble. Okay, so let us take a look at option A, silver and barium. Okay, so we know that silver nitrate, all nitrates is soluble, so silver nitrate is soluble. Silver carbonate is insoluble, that's right. Silver sulphate is soluble. Silver sulphate is soluble because all sulfates are soluble except calcium, lead, and barium. So since silver sulphate is soluble, A is out. Okay, since silver sulphate is soluble, so that eliminates the silver. Okay, and if that eliminates the silver, B is also out because B contains silver as well. Now let's take a look at C. Let's look at barium. Barium nitrate is soluble, that's true. Barium carbonate is insoluble, that's true. Barium sulphate is insoluble, that's true, but barium chloride is soluble. Okay, so barium chloride is soluble, but for this particular metal, the chloride is insoluble. So again, it cannot be C. So that leaves us only with D. So let us check. Lead nitrate is indeed soluble. Lead carbonate is insoluble. Lead sulphate is insoluble. And lead chloride is insoluble. So lead is the only option where all the solubilities of these different salts matches what is in the table. Okay, so the answer for number 3 is D, lead only. Once again, we recap that lead nitrate soluble, lead carbonate is insoluble, lead sulphate is insoluble, and lead chloride is insoluble. Okay, let's go take a look at number 4. Which two solutions will not give any visible change when mixed together? So we are looking for something, a change that is visible. Okay, so let's take a look. Now in this kind of situations, it is useful for us to see whether or not when we get a bunch of chemicals like this, it is sometimes useful for us to exchange ions and see whether we get a precipitate or we recognize any other reactions that produce a gas. Because when a precipitate is formed, or when a gas is formed, there will be a visible change. Okay, I say again, when you get a precipitate or when you get a gas from a reaction, there will be a visible change. So let's take a look at A. Barium nitrate and sodium chloride. If we switch ions, we get barium chloride, which is still soluble, sodium nitrate, which is still soluble. So both products are soluble, and both reactants, barium nitrate and sodium chloride, are also soluble. So you start off with two soluble materials and you end off with two soluble materials. You will not get any visible change. So A is already your answer. But let's take a look and see whether we're correct. Okay, the rest must produce a visible change then. So let's take a look at B. If we switch the ions between calcium nitrate and potassium carbonate, we get calcium carbonate, which we know calcium carbonate is insoluble. So we will get a precipitate. For C, silver nitrate and potassium chloride, if we switch the ions, we will get silver chloride. And again, we know that silver chloride is insoluble. And therefore, we will definitely see a precipitation reaction, very visible. In D, dilute nitric acid and aqueous potassium carbonate. Now, this is a reaction between an acid and a carbonate. And you know that acid, when it reacts with the carbonate, will produce carbon dioxide gas, which means you will observe effervescence, and this is definitely a visible change. Okay, so for B and C, the change that you will see is that a precipitate is formed, and for D, you will observe effervescence. Therefore, the only reaction that doesn't produce any visible change is A, because the two starting materials are both soluble and the two products that are formed are also soluble. So there will be no visible change. Let's take a look at two more before we end off this video. An excess nitric acid is added to a mixture of two white solids. A colorless gas is formed and only some of the mixture dissolves. What could the mixture contain? Okay, so let's look for clues. The first clue that we can get is actually two white solids. Let's see whether there are any solids here which are not white. And we notice that we have copper carbonate. And we know that copper carbonate is green. So, since we are looking at only two white solids, we can automatically eliminate A and D. Okay. Now, we are adding nitric acid and we get a gas. So we see that there are carbonates here. So we know that carbon dioxide is produced. So that doesn't help us narrow down any further. But we also know that only some of the mixture dissolves. Okay, so let's take a look at what happens in B. When we add barium carbonate and nitric acid, we will get barium nitrate, okay, and carbon dioxide and water. Okay, so we can see that this is a soluble substance. Okay, now we add, how about zinc carbonate? Zinc carbonate will follow the same reaction. Zinc carbonate and nitric acid will give us zinc nitrate plus carbon dioxide plus water. And we know that zinc nitrate, barium nitrate, they are both soluble. Remember, all nitrates are soluble. In which case, since the question says only some of the mixture dissolves, it cannot be B, because B produces two soluble substances. Let's take a look at C then. We know that it has zinc carbonate, so it will produce soluble zinc nitrate. But here we have barium sulfate. Now you will remember that barium sulfate is an insoluble salt. All sulfates are soluble except calcium, lead, and barium sulfate. So this barium sulfate will remain insoluble because only some of the mixture dissolves. So leading us to a conclusion that the answer is C. Okay, let's do one last question before we end off this segment of the series on revision of salts. Epsom salts contain magnesium sulfate and are used to treat upset stomachs. Which of the following reagents can be used to prepare magnesium sulfate? And as we remember, all sulfates are soluble except calcium, lead, and barium. So this is a soluble sulfate. And since it is not sodium, potassium, ammonium, we are talking about non-spar sulfate. Okay, a non-spar soluble. So again, for a non-spar soluble material, we use acid and insoluble metal, base, or carbonate. Okay, so since we have to use an acid, this is sulfuric acid, sulfuric acid, sulfuric acid. There is no sulfuric acid in D, so we can automatically eliminate D. Okay, and therefore now we are looking for a metal, base, or carbonate. Now magnesium nitrate is a salt. Magnesium chloride is a salt. Magnesium oxide is a base. Remember, a base is a metal oxide or hydroxide. So since we're looking for an acid plus metal base or carbonate, the answer has to be C. It cannot be A, it cannot be B or D. Okay, so we will end this video here. Look out for the next video where we tackle another 6 questions of a variety of styles. Okay, so look out. I'll see you in the next video. See you soon. Bye bye.